right, that's doing the thing. Okay, good morning, guys. We picked a good day to start working remotely. I don't know if you've been outside in Lubbock, but it's like icy and freezing and terrible. So nobody has to walk across campus, so I guess that's a plus. Today we're gonna dig into Verilog. We're gonna spend some time going through the installation process. We're going to look at how to download it, how to get it running in your text editor or in Visual Studio Code, how to do all of the sort of bells and whistles, and just kind of make sure everything's working properly. So if you don't have, I assume you're watching this stream on your computer, but if you are, I recommend that you follow along with what we're doing. So, make sure you get your laptop out. If you have the Discord running in a separate monitor or something like that, or on your phone, that'd be pretty cool. That way you can follow along. I'll give you guys just like a few minutes to get that set up and get ready, and we'll go ahead and get started at like 11:05. Thank you. Yeah, while we're waiting for folks to get set up, are there any questions, comments, concerns about anything related to the class?
Are you going to be putting up a notes or something on how to do all the different logic operations for this to reference, or are we just going to go through it in class and we have to write it down?
If I think I understand the question correctly, we're going to go through everything in class, everything that I expect you guys to be able to do in Verilog. We're going to do here in class. We'll kind of do it in notes. I'll type up some stuff here in OneNote that you can use. But no, I'm not planning on making a global reference document. Is that kind of your question?
Yes.
Okay. And really, it's not, there's only a handful of things. The syntax of Verilog, you can get deep into it, but as far as what we're going to do in this class, it's not that intense. And so there's not going to be a need for a deep reference material. There's just a handful of operations, and then from there, we're just doing the logic design stuff that we've been talking about in class so far. So hey, let's try a thing real fast. I'm going to turn, it's kind of hot in my lab, and I usually have this fan running. I'm going to turn it on. Does that kind of mess up the audio?
I can't hear anything.
Cool. All right. Well, I'm going to leave my fan on then. Awesome. All right, one more minute, and then we'll get going with installing Verilog. And I've gone ahead and uninstalled Verilog from my computer, as far as I can tell. I think I've eliminated everything. I apologize. I'm going to do this on Windows because that's the computer I have here in my lab. So if you're a Verilog, or excuse me, if you're a macOS MacBook person, then I apologize. The first sort of 10 minutes here won't really apply to you. But a couple weeks ago, I made a video on how to do it specifically in macOS. And for what it's worth, it's much, much easier to install Verilog in macOS. You can use Homebrew to do it. Okay, so everybody's ready. Let's go ahead and get it going. So as I illustrated, or as I said, I've eliminated everything that is Verilog from my computer. Those of you guys who've run into some issues have probably already seen this, right? So if I type in iVerilog, the command, right, it's going to say iVerilog is not recognized. That means that it's not installed properly. By the same token, GTK wave also isn't recognized. I also like to use a couple of different command line tools, such as there's PowerShell, which most of you guys who are using Windows, the command line is going to be what's packed in default. Windows PowerShell is also default, but it's not as commonly used as the command line. Also, I should probably say, before we get into this, I am not going to teach you how to use the command prompt. You guys are, I guess double E's, electrical engineers kind of get a pass, but the computer engineering students, especially the computer science students, I'm going to assume a sort of basic level of computer proficiency. I'm going to assume that you know how to work with the command prompt in Windows. I'm going to assume that if you're a Mac OS user, you know how to use the terminal to run your basic commands. There's really only like 3 commands that you need to know in order to be successful with what we're doing. But like I said, I'm going to expect you guys to know that. So please don't pester me over email with questions about how to use PowerShell or the command prompt. Okay, so let's see. Same thing in PowerShell, Verilog. It's not there. It doesn't exist. For those of you guys who are really advanced, there's PowerShell 7, which is like a pretty souped up version. It doesn't come default with Windows. You have to install it separately. It's what I prefer to use. And you can see that iVerilog is not installed. So what we need to do is go to the website and download it. And finding it is not the easiest thing in the world. Their website is not the most user-friendly. So the website here is iverilog.icarus.com. It's where they host this open source project, Icarus Verilog. And Icarus Verilog is just you can think of it as the compiler for Verilog. It'll take our Verilog code and synthesize it into an actual logic circuit and let us simulate the output. And if we had an FPGA or a programmable logic device, it would also let us push that binary data to that logic device. So you kind of go to the website, and it's, like I said, it's really not very easy to figure out what's going on. And sometimes I forget where it is. But yeah, so where is Icarus Verilog? So it says, note, this is a quick summary of where to get Icarus Verilog. For more complete download and install instructions, look here. So you can click on this little link that's hiding right over there. It's going to take us to the installation guide, and it's going to show us pretty much every variant of how to install Icarus Verilog on any machine or any operating system. Again, we're working on Windows today, because that's the computer that I have, and the Windows install is like all the way at the bottom. And so basically they just give us this other link, Windows binaries wrapped, and a handy installer are available from this guy named Pablo. So let's click on that link. And it takes us back to this bleyer.org, bleyer.org/Icarus, and he's got all the download stuff that you need. So what we're going to grab here is the latest version for 64-bit Windows, and we're going to grab it and let it download. And then I'm going to open up my downloads folder. Make sure I have anything weird in my downloads folder. Cool. All right. And then I've got the setup application for Icarus Verilog. I'm going to double click on it. Windows is going to get mad and say, this is malware, please don't do it. Hit more info, and then hit run anyway to say, nah man, we know what we're doing. This is what we want. And then from there, it basically goes through the standard Windows installation process. We're going to accept. We're going to hit next. We're going to give it a default install location. We want to also install the dependencies, especially GTK wave. That's how we're going to view our waveforms, our timing diagrams, like we've done in class. We'll hit next. Everything is, whoa, where'd it go? It disappeared. Okay, hit next. Now here's a really important part. Yeah, Esteban, you do need to download this. Otherwise, you won't be able to do it. Here's a really important part. Everyone messes it up. If you watched the previous video and it didn't quite work, here is why it didn't work. You need to check this box right here, add executable folders to the user path, right? If you don't do this, then your command line tools won't know that iVerilog is installed, and you'll get that iVerilog is not recognized error. So make sure you check this box, add executable folders to the user path. And then we hit next, and then we hit install, and it's going to do the stuff. Esteban, I'm showing you how to download it and do it right now. But yes, I also sent you a video. Well, we'll catch up, man. I'll try to slow down. So, and there we go. Hit finish. And And I should be able to, now if I go right now to PowerShell or command prompt or something, let's close some stuff. Type in Verilog, it might still not work, right? Because command prompt was open and running before I finished the installation. So I'm gonna close all of these guys out. If I did go a little bit quick, and for some of those of you guys who maybe missed the installation link, it's this right here, bleyer.org/Icarus, and then you want to grab that most recent version, the one at the top of the list. And again, I'm doing this on Windows. If you're doing this on Mac, everything I'm doing right now won't apply to you. Go watch the other video that I made for Mac. It's a lot easier to install it for Mac. And so follow that, and then of course email me if you have any questions. All right, so now let's go ahead and bring back the command prompt, see if everything worked. Hey, look at that. So I typed in iVerilog now, it says iVerilog no source files. So iVerilog has thrown an error here and said, hey, you didn't give me anything to work with, but this shows us that the command worked, that iVerilog executed, and that our install is done correctly. The other tool we need is GTK Wave. So if I type that, it should pop open and give me an empty user interface for GTK Wave. So from there, let's go ahead and get us a logic circuit. Actually, are there any questions about that, or anything that you want to see one more time before we actually move on and write some Verilog code? I'll wait a minute. You can find the video. Let me pull it up real quick on my YouTube channel. So remember to like and subscribe. Here, I'm gonna grab the link for you. Don't do it, don't play it. All right, there we go. Share. There you go. I just did it in the chat. That's how you do it in Mac OS. And like I said, it's a lot easier to do it in Mac than it is in Windows. Okay. All right. So, any other questions? Tam asks, Tam asks, how can you, or can you show how to install Verilog in VS Code as well? I'm glad you asked for that. We're actually, you don't install Verilog in VS Code. I'm going to talk about what that means here in a minute, but no, you don't actually, there is no installing Verilog on VS Code. VS Code is just a text editor. Evan asks, also, okay, hold on, one thing at a time. Evan asks, how do you open the GTK Wave window? You just go to the command prompt, and type in GTK Wave, and it'll pop open that window for you.
Did you ever send out that email I sent you to the other students?
With the batch file? Not yet. I was gonna do this first, and then I'll send that out. I was gonna send that out today.
Okay.
Yeah. What he's talking about is he made a batch file that runs on Windows. As you'll see when we do some of these, we can there's like 3 commands that you have to do in sequence in order to get everything to work properly. It's Devin, right?
Yes.
So, yeah. Devin wrote a batch file that lets you just do it all in one line, which is pretty slick. So, and I'll share that with the class later. Okay. Cody asks, Visual Studio, question mark? No, we're not going to use Visual Studio. We're going to use Visual Studio Code, right? So, let me just... So, if I bring this over and say Visual... Actually, You stick to my flow here. Over here, Visual. So Visual Studio, right, is what you guys use in your CS classes, right? So that's Visual Studio, which is for doing stuff like C++ and all kinds of crazy stuff. What we're going to use is this guy, Visual Studio Code, or it's what I use is Visual Studio Code, just because I prefer it. It's an extensible text editor. If you've ever seen anything, if you're familiar with like Notepad++, yeah, Esteban, I'll give you 5 minutes to download the application and get it going. If you've worked with anything like Notepad++, or maybe Brackets, or Atom, I think those are the big ones. Visual Studio Code is just like that. It's a text editor. In fact, to kind of illustrate that you don't need to install anything, I'm going to do our first bit of Verilog coding just in Notepad itself. So like basic vanilla Notepad. And I'll give the Mac OS folks a few minutes to kind of catch up. See, Cody are there any resources that you can use to learn basic command prompt stuff? No, yes, you can certainly look up. I think if I just go over here and, I don't know, let's Google, Windows command prompt tutorial. Oh, yeah. So I did a quick Google search of that, and there's like, this one, learn command prompts in 15 minutes. There's all kinds of tutorials online for how to use it. And again, you really only need to know a few basic things. And honestly, we'll talk about all the stuff that you need here today. So that's that. We'll give, like I said, about 2 or 3 minutes for the Mac OS folks to finish up. While we're waiting on that, are there any other questions, comments, concerns?
Why did you choose Verilog instead of projects?
Hey, could you say that again? Your audio was pretty choppy.
Why did you choose Verilog at we choose instead of something else?
Well, because for starters, okay, so the question was, why did I choose Verilog over as opposed to anything else? The answer to that question is there are only actually 2 options for hardware description language. There are hold on, Julian asks, download Visual Studio Code, correct? Yes, you can. You don't have to, though, if you don't want to. We're going to use, I'm going to use Notepad for the most of today, just to illustrate that I don't want people to get hung up on Visual Studio Code as the place where Verilog lives, because that's not true. But anyway, the question was, well, why Verilog is opposed to something else? There are really only 2 hardware description languages. There's Verilog, and then there's a language called VHDL. And the course textbook uses VHDL. And the reason we still went with Verilog is because here at Texas Tech in our department for the advanced classes, this is really more relevant for the computer engineering majors. But as you move forward, you get to Project Lab 1, the computer architecture class here. The more advanced classes in our department use Verilog, so we decided to just stick with Verilog in this class. It's also a lot easier. The designers of Verilog went kind of out of their way to make it seem more like a traditional programming language. It's going to feel more like programming in C or C++, whereas VHDL is like its own weird monster that has very little in common with a regular programming language. Let's see. Joshua asks, if the path to our code files has folders that contain spaces, will that cause a problem? Or was it only during installation where spaces would cause a problem? Yes and yes. Unless you know what you're doing, I don't recommend including spaces in your folders or your file names or anything like that. You can do it. One way to get around it, or actually, well, here, we got some time. Let's go ahead and talk about that. Let me do this. I'm gonna make a new folder, mkdir, make directory, makes a folder, and I'm gonna call it my folder. Actually, hold on, let's do a couple things. dir lets me see everything that's in.
We can't see the command prompt you're using.
Oh, gotta switch over to my other screen. Good catch. Okay. So let me go back and do this again. So if I type in dir, that lets us view all the files in the current directory that I'm navigated to. So you can see a lot of like basic stuff. You know, my OneDrive folder. Some of these weird ones. What is this? Like Bunny Ball. That was a Unity tutorial project. So that lets you view what's in here. And then if I want to make a directory, I'll say like make dir, and I'll try it with spaces first to see what happens. Make my directory. So I did that. It didn't throw any errors, but let's look and see at dir. Hey, look at that. There's a my folder now, and but there's a directory folder, right? So it created 2 folders when I did it that way. Now, if you want to include spaces, you can put them in quotes. I think my directory. Now let's take a look. And yeah, here's my directory with spaces in it. If you want to move into a folder, you use the cd command. Cd for change directory. Esteban, you got to be a lot more specific than that. I can't really help you with nothing happens. I am not at your computer. Okay, so if you want to navigate to a directory, use the change directory command, so cd, and then the name of the thing. So if I want to navigate to this directory folder that we created, I would say cd directory. And now you can see from my path that I'm in that directory folder. If you want to go back the other way, I'm going to do cd ... And now I'm back in my root folder, my user folder. If I want to navigate to a folder with spaces now, I have to put it all in quotes. My directory. There it goes like that. Now I'm in the my directory folder. Now, oftentimes though, other programs that you use may not have this syntax built into it. They may not be using quotes in their paths or anything like that. So having spaces in your folders, even if you know what you're doing, a program that you're using might still get screwed up by that. So it's usually best to do something like, if you want to include spaces, the best practice would be to say, you know, make directory my underscore directory. The convention is just to use underscores as your thing. If you want to remove a directory, rmdir, I think. Let's see, let's remove everything. My directory, my underscore directory, and my directory. And then, yeah, those guys are all gone. Cool. All right. So we've got to move on to actually doing some Verilog now. So let's do that. In fact, actually, the first thing we want to do is pop open Notepad real fast. We need a circuit in order to design. All right. Esteban, I'm sorry to hear that you're having trouble. We're going to keep moving on, but feel free to come by my office hours today and chat, and we can get one-on-one and fix whatever it is that you're struggling with. So, okay. The first thing we need is a circuit to mess with, right? So let's do a really simple one. Let's do an input A, an input B, an input C. And let's just do an AND gate. To F, and let's have another circuit. It's an OR gate. Let's call it G. And that'll also take from A, B, and C. So that's our logic circuit. It doesn't get much easier than that. We're doing, oops, people are typing questions. F just is an AND gate. G is an OR gate. And so it is a Boolean expression. We would say that f is a function of a, b, and c, and it's just equal to a and b and c. And g is also a function of a, b, and c, and is equal to a or b or c. Joshua says, I'm pretty sure you can use regular Notepad, but it gets a lot easier to keep track of things if you get VS Code or Notepad++. You're absolutely correct. We're going to start with Notepad just because, like I said, a lot of people get really hung up. You're very used to like Visual Studio doing C++, where like everything kind of lives in Visual Studio. Verilog is not like that, so we're going to start with Notepad, and we'll show how we can use VS Code or Notepad++ to make life easier. But that's not where we're going to start. So here is the logic circuit that we're making, right? F is equal to A and B and C, and G is equal to A or B or C, right? We're going to illustrate how to use some basic logic gates. So let's go ahead and make our Verilog file. So make sure you know what that is. F is equal to A and B and C. G is equal to A or B or C. So I'm going to start off just by using Notepad. So this is basic vanilla Notepad. I'm going to hit Control S to save my file. And I'm just going to go right here to the C drive. I'm going to make a new folder. I'm going to call it ECE 2372. I'm going to open that up, and I'm going to say, let's call this, I don't know, circuit1.v, just to give it a name that means something. So now it's a Verilog file. If I go over to here and I go cd to ECE 2372, what did I call it? Oh, I did it in the other drive, so I'm going to go back. CD. I did really fast. Let me recap what I did there just a second ago. So I saved those folders in. Pull the command prompt back up. I had saved these guys under the local disk C, ECE 2372 circuit 1. But notice that my command prompt is currently at my user folder. So I need to get back to just the C drive. So I want to go back up through my user folder, then through the users folder. So I'm going to do this, cd .. to go up 2 levels. Hit enter. Now I'm in the C drive. Some of you may have seen me really fast screw up and do ls. If you're using Mac OS or like a Unix shell, ls is the same thing as dir. And we can see that ECE 2372 is right there. So now I want to go cd ECE 2372 and hit dir again. And now I can see my circuit1.v file has 0 bytes. It's got no text, so it's totally empty. But there it is. It exists. And we can do stuff with it. Now let's get into the Verilog. Can I maybe increase the font size here? Let's bump it up to 20 just to make it a little easier for you guys to read. Okay, so Verilog happens in, I am about to use Notepad to write code because I'm hardcore like that. So Verilog happens in modules, right? You're gonna, every circuit that you build, right? In class we called it a logic circuit. A logic circuit becomes a Verilog module. So if I say implement a logic circuit in Verilog, you're gonna make a module. So it's 2 caps, module and in module. Just like that. Now we need to give our module a name. By convention, you usually give your module the name of the file, like the file name and the module name should be the same. So I'm going to call this circuit1, and then we're going to open and close parentheses and put a semicolon there at the end. And inside the parentheses, we're going to put everything that was in our logic circuit. all the inputs and outputs. So we had A, B, C on the input side, and F and G. So we're going to dump those in. A, B, C, F, and G. And we're not going to make any distinction between inputs and outputs yet. You would use, I think it's called Text Edit on a Mac, is the Mac version of Notepad. It's in there somewhere. Pull up the Launchpad. Dig deep. It's in there somewhere. The question was, how do we do this on a Mac? Yeah. Let's see. So there we go. I'm going to hit save. Now the next thing I need to do is define my inputs and outputs. So actually the first thing I'm going to do is make a comment. So 2 slashes. Hopefully you're familiar with comments from other programming languages. Double slash in Verilog is the comment for Verilog. So I'm going to say input declarations. So I'm going to say an input A is an input, B is an input, and input C. Just like that, and save. I also could have done this. I could have said A, well, something like this, input A, comma B, comma C. That would work just fine. But by sort of best practice convention, we tend to list everything out. And this will matter when stuff is different size bits, right? So when we have data inputs and control inputs that are different sizes, generally we just kind of list everything vertically, but both are fine. If you do this on your assignments, it's all good. Don't worry about it. So, but I'm going to stick with this. Now my output declarations, output F, and output G. So there's inputs and outputs. So even though here at the top in our module declaration here, we just gave them all as parameters, here we're actually going to define them each individually as inputs and outputs. Then finally, there's just our logic implementation. So to create a logic gate, we're just going to do what's called an assignment. So we're going to type out assign F is equal to, now remember from our circuit that we drew, F was equal to A and B and C. It's going to look like this, A and B and C. And then we'll assign G, which was A or B or C, A or B or C. So the ampersand signal for and the vertical bar symbol for or. So we'll say this is A. So ampersand equals and, vertical bar equals or. What questions do you guys have? Is there a difference between uppercase letters and lowercase letters in Verilog? Yes, absolutely. Verilog is a case-sensitive programming language. So uppercase and lowercase letters matter. And there we go. There is our first working logic circuit in Verilog. There's not much to it, but it's got some inputs, it's got some outputs, and it's got some logic implementation. Now, by itself, though, there's really not a whole lot we can do with this. We could synthesize it. We could make it into, yeah, there's really nothing we can do with this. If we were going to push it to an FPGA, we could stop here. But what you need to do is for every module that you make in Verilog, you need to have a corresponding, what we call a test bench file. And a test bench is where we actually simulate the behavior of the circuit to make sure that it's doing what we want it to be doing. So I'm going to create a new Notepad document. And I'm going to save this as circuit1 underscore. So usually by convention, this is what I do. I'll do the name of the module underscore TB for test bench and then it's also a Verilog file. Let me do. Let me keep this circuit open. Like that. And then so we're going to need a test bench here. Cool. All right. Let's see. If I type dir in my command line, I can see that now that I've got circuit1.v, which itself now is 243 bytes, and circuit1_tb exists but is at 0 bytes. So let's go ahead and write our test bench, and there's some interesting things that go on here. The first one is that we need to define a time scale. Remember when we were drawing logic diagrams, or let me back up a second and say, test benches basically are going to make the timing diagrams for us. You know, we've done them by hand in class to look at things like logic hazards and stuff like that, but now we're going to use the test bench to generate an automatic timing diagram. So we can look at a timing diagram waveform and see what it looks like. But remember that we had to define what our timing was, and so the first thing we need to do is do apostrophe. Now here's the thing that gets a lot of people. When I say apostrophe, I mean apostrophe, not single quote. Right? Does everyone see the difference? The apostrophe on the standard American keyboard is with the tilde symbol. It's above the tab. So I could do tilde or apostrophe. Is everyone clear on that? If you don't do apostrophe, it won't work. If you do single quotes, almost everyone does single quotes, and then what we're supposed to do, make sure you use an apostrophe, and then it's time scale. And we're going to use, by convention, 1 nanosecond / 1 nanosecond. Now what that means is the time unit / the time resolution. What that means is the first one, 1 nanosecond, means when we declare a unit of time, it's going to be 1 nanosecond. And then time resolution means that if it has to do some sophisticated stuff, right? If probably time resolution won't really come up in what we do in this class, but if you had to do some really advanced timing and the simulator needs to round some values, it's going to round to the nearest 1 nanosecond in this case. So whatever we put here is our time unit that's defined in code, and then here we're telling the simulator round everything to that amount. And by just default, I always use 1 nanosecond, 1 nanosecond, because we're always doing some pretty basic simulations. And, well, it's not that big a deal. All right, the next thing we need to do is include our module. So again, apostrophe, not single quotes, include, and then in double quotes, the circuit1.v. So we need to actually bring in the module that we created and so that we can use it in our test bench. Now we're ready to actually write the test bench itself. Now a Verilog test bench is a module, so we're going to say module circuit1_tb_tb, but we're going to have no parameters. It has no inputs or outputs. It's just declaring, or it's creating an instance of our module that we created, and it's going to test it, but it itself has no inputs or outputs. So we just leave those parentheses blank, and in fact, I think we can actually probably just do that and not even include the parentheses. If that throws an error, we'll find out when we go to synthesize. And then we have in module there at the end. Okay, the next thing is going to get kind of weird. We need to just define our inputs, outputs, and what we call our unit under test, our UT. I don't want you to worry about this next part. Just remember this fact. For inputs, you're going to use registers. So REG A, REG B, REG C. And for outputs, you're going to use wires. Wire F and wire G. Do not worry about why that is the case. Just remember that for inputs, use regs. For outputs, use wires. We will talk about what regs and wires are way down the road. in a basic sense, we use regs for inputs because reg variables let us assign values to them. We can put values in regs, and wires we can't. Wires just carry signals, so that's why they're inputs and outputs. So remember, regs for inputs, wires for outputs. So we define everything, and it's always good to make sure it matches, that it lines up pretty clearly with, or lines up directly with what we declared in our circuit. Now the next thing we need to do is our unit under test. So this is, we're going to create the instance of the module that we want to test. So if you've ever done any object-oriented programming, this is going to look an awful lot like just creating an instance of a class or creating a class object. So first off is the name of the module we want to use, right? In this case, it was the module circuit1. And then we need to give it an identifier. By convention, I usually just give it the identifier UUT for unit under test. And then in parentheses, we lay out our inputs and outputs just like we had F, A, B, C, F, and G. Oh, except I put it in the wrong place. That should go up there with circuit 1. Okay. So now that we've got everything set up, we can actually run the simulation. So we're gonna do this initial, and then begin and end. Verilog does not use curly braces, right? So in C++, you might see something that looks like that. Verilog doesn't do that. The equivalent thing in Verilog is to say begin and end. And now we do the stuff. So we need to start by setting values to our signals, and let's just set everything to 0. So we'll say A equals 0, B equals 0, C equals 0. And then we need to delay for some amount of time. So to do a time delay, I'm going to use the hashtag, the octothorpe, the pound sign, whatever you call it. And I'm going to go ahead and delay for 20 units. Now don't forget, where did we define what that means? We defined it up here in our timescale. So here is where that matters, right? Because we said timescale 1 unit of time is 1 nanosecond. Here, this means that we're going to delay for 20 nanoseconds. And then let's do a transition. Let's make C equal 1. And let's go ahead and delay for, I don't know, let's delay for 50 nanoseconds. And then set C equal to 0. No, actually, let's do this. So what we would expect to see, since remember G is an OR statement, at this, when we set C equal to 1, we would expect G to go to 1, and then let's see if we can get A to go to 1. So after 50 nanoseconds, let's set the other two. Let's set A equal 1 and B equal 1, and then we'll delay 20 nanoseconds just to keep things going, and then we're going to wrap things up with a finish. This will just tell the simulator that, hey, we're done, and that you don't need to hang on any longer. So let's see. We had some pieces. All right, so let's recap. We had initial begin, A equals 0, B equals 0, C equals 0. We set all our inputs to 0. We're going to wait for 20 nanoseconds, and then we'll set to C equal to 1 and see what happens. Wait for 50 nanoseconds, and then we'll set A equals 1 and B equals 1, so then everything will be 1. So we should see F go to 1. Wait 20 more nanoseconds just so we have time to see what happened, and then we finish our simulation. The last thing we need to do is define where stuff is going to go. And so we need to actually create a waveform file to view. And the way that works is by doing $dump file. And I'm going to call it circuit1.vcd. That's our GTK wave simulation file. And then dump vars is, well, where are we going to get the data from? The first parameter, you're always going to use 0. and then it's just going to be circuit1_TB, the name of our test bench. Just like that. So doing this will create the waveform file that we need. All right, and then we'll go ahead and save it, and that is everything that we need in order to do our test bench. So remember, we set our timescale, we included our module that we wanted to test, we created our test bench module, we defined inputs using registers, outputs using wires, we instantiated our unit under test module, we set up our waveform file, then we ran a simulation, a really simple one, by just setting all the values to 0, waiting for 20 nanoseconds, then transitioning C from 0 to 1, waiting 50 more nanoseconds, and then we transitioned A and B to 1 and waited 20, and then finished our test bench. If you want to get some, well, never mind. Let's just run this and see what happens. So before we do that, are there any questions about the code that we just wrote? Okay. Oh, someone's typing. Is it in module? Is in module the end of the whole program? Yes. I'm gonna be a bit of a stickler and say don't call it the end of the program, because it's the end of the module and program means something else. But yes, it's the end of the Verilog file. Let's see. Young asks, I've no questions really, but I can't find my apostrophe button. I don't remember off the top of my head where the apostrophe is on the. If you're using a Windows or a sort of standard keyboard, it's going to be on the left-hand side above the tab key. I don't remember off the top of my head where it is on the Mac OS keyboard or the Apple keyboard, but I think it's in the same place. Valeria asks, do space bars matter? Yes and no. I mean, obviously for some commands things matter. So for example, saying like initial begin without a space, that won't work. But you could do stuff like that where you don't use whitespace. However, if you do that, then you are a monster and should be ashamed of yourself. So don't always use whitespace, guys, when you're writing code. Good readable code includes whitespace. Only lazy programmers don't use whitespace. So
put all your code on one single line.
Yeah, write it all in one line, just separated by, you start doing stupid nonsense like this where you just like attach everything, no white space, everything is all in one line, just like that. Don't do that. Don't be that person. Okay, we're almost out of time and we need to run this simulation. Anything that represents, okay, that was a good question. Carlton asks, anything that represents a bracket, or quote unquote, a bracket has no semicolon? Correct. Yeah, Ethan, if you don't use whitespace, then I'm calling you out. I'm going to take a hard stand on that. Whitespace matters. Okay, we're almost out of time, so let's go ahead and run this simulation just to make sure that it worked. So here's the good part. If you were kind of zoning out for a lot of that, pay attention right now. The commands are thus. It's going to be iverilog, obviously is the command that we want to run, -o. Don't worry about what the option O means. If you care, you can look it up in the documentation. But just know it's -o, and then I'm going to say circuit1.vvp. So this is the simulation file that we want to create, and we're going to create it from circuit1_tb.v. So that's the command to create our simulation, and it won't run our simulation. It will create the simulation file, and then if we had any syntax errors, they will appear right now. So maybe we'll have some. Oh, look at that. So circuit1_tb.v at 36, it says a syntax error. So those of you who aren't familiar with debugging yet, Verilog oftentimes throws some pretty cryptic error messages, but the important thing is it says, hey, something is messed up at line 36 of our test bench file, and here's where I immediately regret using Notepad because it doesn't have line numbering, but I'm going to bet that it's this one. Yeah, okay, check this out. Here's the thing. This is important. This matters. This is a good example. So the syntax error said it was at line 36. down here, Notepad is nice enough to actually tell me what my line numbers are. 36 is here. And there's just the end, right? There's nothing wrong with that. What actually happened was I missed a semicolon at the end of finish. And what happened there was if you forget a semicolon, the syntax error actually won't appear until the next line of code. So that's why, even though it said 36, it was because I was missing a semicolon up there at line 34. So let's save that. Another command line trick, if you just did a command, hit the up arrow, and it will create a new, it'll basically just populate the command prompt with the command that you just did. So let's run it again. If it doesn't say anything, then all is well, and we had no syntax errors. And then to actually run the simulation, we'll do VVP, or actually let's do this real fast, dir. Now check this out, we have a new file, circuit1.vvp, that's 2.7 kilobytes. So it's got a lot of additional information in it. Now we run VVP, circuit1.vvp. This runs our simulation. And if everything went correctly, it just says, hey, dump file, circuit1.vcd opened for output. It says we created our waveform folder. Let's run dir again, and here, check this out. We also have now a 498 byte circuit1.vcd waveform file. Last thing we want to do is view that waveform file to actually make sure that our stuff, worked correctly. There's two ways to do that. We can do it this way: GTK wave to open GTK wave, and say file, open new tab, and then open r.vcd file. Or a better way to do it is to just, when you type in the GTK wave command, GTK wave, give it the name of the file you want to open. So I'm going to say GTK wave space circuit1.vcd. Now it will load with my circuit already cooking in there. So now I've got my circuit1 underscore testbench module. Check it out, I've got my UUT, the unit under test that I created. When I'll come down, I've got all my signals, my regs, my wires. I'm going to use shift or hold, you can hold control, right, to select all of them. Or you can select one and go down to the bottom and hold shift to grab this one. And we want to hit append. And that actually brings our waveform folder, our waveform file out. Let's see, we can do some things. And it looks like it's probably working. So check this out. So if I click here in the waveform, here on the left-hand side, it'll give me what all these values are. So in the beginning, everything was 0. That's sort of as we expected. Then here at 20 nanoseconds, everything, let's see, C went to 1. And then so G, which was the OR gate, went to 1. That's expected. We waited 50 nanoseconds. So at 70 nanoseconds, we can see here that A and B also went to 1. And then F also went to 1. So from there, we can see that our waveform, that our circuit's working the way we expected. Excuse me. So there we go. We're actually out of time. So what questions do you have about what we've done so far? If any questions. Okay, in that case, we will pick up right here where we left off. We'll start with this signal. We'll get into VS Code. We'll talk about how to use Visual Studio Code or a better editor to make it a little bit easier to work with. VS Code's great because it has a built-in command prompt or built-in PowerShell. We'll talk about how to do that, and then we'll move on to some more advanced Verilog code on Wednesday. And on Wednesday, you'll probably get your first Verilog project to start working on. So if there's nothing else, thank you so much. Yeah, I'll see you guys on Wednesday. No problem. I think it's fun.